Boyle's law says that volume and pressure are inversely related when temperature is held constant. In other words, when volume goes down, as we can see in this picture on the left, the volume is going down and pressure is going up. When we have a larger volume, we have a smaller pressure. The equation that we use for Boyle's law is P1 V1 equals P2 V2. Our 1s are for initial pressure and volume, and our 2s are for final pressure and volume. It doesn't really matter what you classify as initial and final as long as values that go together are put together, as we'll see in this first example. The first thing you want to do is label all of your substances or values. So it says we have a gas and it's known to have a volume, so that's going to be V1. So that's the first one I came to. When the pressure is known to be 754. Notice that volume goes with this pressure, so this must be P1. What would be the volume? So V2 is what I don't know. When the pressure is changed to, so this is P2. So, because I have pressure and volume, I'm going to write my equation, which is Boyle's law. I'm going to circle what I don't know and rearrange the equation. You do have to show the rearranged equation. So, to get V2 by itself, I divide by P2. And again, you need to have this equation written on your paper. So now we can start plugging in. I put P1 on top. V1 on top. And P2 on bottom. You can put P2 anywhere on the bottom, but I like to put it under P1. So then I can easily see that my units do not cancel out and that I need to convert one of them. Doesn't matter which one you convert. I'll go and convert the ATM to torr. There's one ATM in every 760 torr, which we saw previously. Make sure that you're canceling your units. Again, that's the whole reason for setting it up in a dimensional analysis table, is so I can see that torr cancel, ATM cancel, and I'm left with liters. So I plug that in the calculator. Remember, multiply everything on top, divide on bottom. So it should be 754 times 7.81 divided by 1.23 divided by 760. Make sure you plug that in the calculator and you should get 6.2999. Again, do not just take my word for it. Plug it in the calculator and make sure that's what you're getting so you don't make simple calculator mistakes on quizzes and tests. Finally, I'm going to look up at the problem. This one had 3 sig figs, 3 sig figs, and 3 significant figures. So I need 3 sig figs. So that 9 is going to round up, making 6.30 liters. Go ahead and pause the video and try this one on your own. Remember to label all of your values in the problem, write your equation, rearrange the equation, and finally plug in all your values. Restart when you have an answer. So when you were labeling it, you should have gotten P1, P2. This is V2 because it says that when the pressure was reduced. So the smaller pressure is 499, so this has to be V2. And I'm looking for the original volume. So plugging my values in. Notice in this case, my torr cancel out. And I'm going to be left with milliliters. I want 3 significant figures, so I get that as my answer. Charles's law says volume and temperature are directly related when pressure is held constant. So if we look at our picture, when we're at a low temperature, we have a low volume or smaller volume. And at a higher temperature, we're going to have a larger volume because the molecules are colliding more often, expanding. In this case, volume and temperature are on top of each other. Anytime they're on top of each other, that's going to be a direct relationship. Increased volume, increased temperature. While in the previous equation, they were inversely related. Notice they're next to each other. So next to each other is inverse, on top of each other is a direct relationship. And just all of your temperatures must be in Kelvin. It doesn't matter what your volume's in, just like it didn't matter what your pressure's in, but temperature must be in Kelvin. And that goes for all equations in this gas law unit. If it's not in Kelvin, it will not come out to the correct answer. So looking at this first equation, again, step one is label your values in the problem. So liters is volume, so it's V1, is heated, so this is T1. And go ahead and convert that temperature right there. 25 plus 273 is equal to 298. And then 100 degrees, so that's T2. So add 273 is 373. It says, what is the volume? So V2 is what I do not know. So now I write my equation. I need the equation that has volume and temperature, which is Charles's law. And I'm rearranging for V2. So circle it. And to solve for it, the easiest way to solve for it, besides using algebra, is to cross multiply. Whichever side your variable is not in, or whichever diagonal your variable is not in, will go on top. Then the things that are not circled or in that diagonal will go on bottom. So V1 times T2 over T1 is equal to V2. Or you could just multiply by T2. Now that I have my rearranged equation, I can plug everything in. I've already converted my temperature, so I'm good to just start plugging in. Make sure you're putting units on your values as you plug them in. And be very careful about your 1s and 2s. That's why we label them, so we can just look up and find them. And again, temperature can go anywhere on the bottom. I just like it right underneath the other temperature so I can easily cancel my values. And see that my answer will be in liters. Plugging that in the calculator, and then looking up at the problem, I want two significant figures. So that's going to be 6.5. Go ahead and label the values in the problem and then restart, make sure you're correct, and then you can solve the problem. So in this problem, notice that 2 cancel out because they're both 700, so I can ignore that. Charles's law was, remember, if you increase volume, you increase temperature, or vice versa, as long as pressure is held constant. Your temperatures, you should have got 327 and 293, and that's our V1. Go ahead and write your equation, rearrange it, and solve. Restart when you've got the answer. So solving that out, you should have gotten 2.88 feet cubed. Gay-Lussacs law says that pressure and temperature are also directly related when volume's held constant. So again, because they're directly related, they're on top of each other. So if I increase pressure, I'm going to increase temperature. Or if I increase temperature, pressure is going to increase due to more collisions. Just like before, my temperature has to be in Kelvin. So this one doesn't involve any math. It says what's going to happen to the temperature of a gas in a rigid container, so volume's held constant, if the pressure's increased 1.65 times. Well, if the pressure's increased 1.65 times, then the temperature should also be increased 1.65 times. But specifically, the Kelvin temperature will be increased 1.65 times. So that's your answer. So on your test, you will have some that are qualitative, like this one, where we didn't actually need any math involved to solve the problem. We just had to know the relationship between pressure and temperature in this case. Go ahead and pause the video and label all of your values in the problem. Restart when you've labeled your values. Okay, you should have gotten those values, 294K and 308K. Write your equation and rearrange it. Restart when you have an answer. So you should have gotten 233 torr. Notice for our rearranged equation, we were looking for P2. So again, P1 and T2 should have went on top. T1 should be on bottom. My units cancel, so I'm multiplying and dividing, and I wanted 3 significant figures. We're not looking at temperature because when I convert it to Kelvin, I have a different number of sig figs. So don't look at temperature when you're finding your sig figs. Look at everything but temperature. The combined gas law is a combination of Boyles, Charles, and Gay-Lussacs. So if you forget an equation, if you only remember the combined gas law, you can technically solve any of the other problems. If they don't say anything about temperature, ignore temperature and you have Boyle's law. If they don't say anything about volume, ignore it and you have Gay-Lussacs law. Or if they don't say anything about pressure, ignore it and you have Charles's law. So everything's the same as before. We use this equation when all 3 things are changing, so pressure, temperature, and volume. And just as before, temperature must be in Kelvin. So let's look at this first one. First, just like before, we're going to label everything. It says that we have a volume. Here's my temperature. And my pressure. It looks like you aren't given enough information because I only have 1 temperature, 1 pressure, and 1 volume. But remember, we're at STP, which stands for standard temperature and pressure. Standard temperature is 273 Kelvin, or 0 degrees Celsius. Standard pressure is any of my pressure conversions. Because P1 is in kPa, I should use the kPa standard pressure. Now, just like before, I'm going to write my equation. Circle what I'm looking for. So this was T2 and P2. So I'm looking for V2. And this is where the cross multiplying comes in handy. That diagonal does not have my missing variable, so it's going to go on top. Everything else goes on bottom. So T1 and P2 will go on bottom. And that's my rearranged equation. So now I just plug everything in. And again, your P2 and T1 can go anywhere on the bottom. It is handy if you put them underneath the P1 and the T1. So you can double check that those units are crossing. Now I can easily see that my final answer is going to be in liters. Just like before, make sure that you actually plug this value in. You should get that value. Then we look up and we want 3 significant figures. So 7.27 liters. Let's do one more together. So again, first we're going to label all of our variables. So we have V1, T1, T1, T2, and P2. I'm looking for V2, so I'm going to write my equation. And rearrange. I'm going to pause the video, plug in your values, and then restart to see if you've got the correct answer. So you should have gotten 1.45 liters. If you didn't get 1.45 liters, pause and look at the equation and see where you messed up. If you have those same values, then re-plug it in the calculator. I'm going to pause the video and try this one on your own. Restart when you have a final answer. You should have gotten 880 torr. Make sure on your paper that you have all the things that I did. That you have a rearranged equation, that you showed all your work with units, and that you have your final answer, again, with units. And that you've labeled all the pieces in your equation. You need those 4 pieces to get full credit. Finally, Avogadro's law. Moles and volume also have a direct relationship, as would moles and pressure. So the equation's V1 over N1 equals V2 over N2. While V1 is initial volume and N1 is initial moles. Your units of volume do need to be the same. So we know this one's Avogadro's law because it talks about moles and volume. And then I have another mole. So I have 2 moles and I have 2 volumes. So that's going to be N1. That's V1. You do have to read the problem. Don't just start writing your variables. Because if I read carefully, it says an additional amount of moles was added. So N2 is not 0.250 because I already had some moles in the container. N2 is 0.150 plus 0.250. So you do have to read carefully on some of these problems. And then we're looking for V2. I write my equation. And I'm solving for V2. Plug it all in. And V2 in 3 significant figures is 9.60. And again, I need that 0 at the end to have 3 sig figs. I'm going to pause this video and try this last one on your own. Restart when you have a final answer. So you should have gotten 8.24 moles because, again, we needed 3 significant figures. Make sure, again, you have your rearranged equation, everything's labeled, and you've shown all work. If you did not get that answer, pause the video and see where you went wrong.